Hello class, this is lesson 16.3 which talks about sector area. So in this lesson the goal is to determine the formula for the area and arc length of a sector. So we're going to start with the area of a sector. Now let's talk about what a sector is. A sector is a region of a circle created by an arc. So with a central angle forms an arc. Now this shaded region is the sector area. So remember from lesson 16.1 where we talked about area of a circle. Remember that the formula for area of a circle was pi r squared. So that was to find the area of the entire circle. But if you just want to find the area of a sector, we need to modify this equation so that we have the fraction times pi r squared. So the formula would be this. Area equals m over 360 times pi r squared. Now m, that's going to be the angle, the central angle, and then out of 360 because a circle is out of 360. Pi 3.14 and then the radius. So to start, let's just look at a couple of examples and then you'll have a chance to work on these on your own. Now what they want you to do in this lesson, they want you to write your answer in two forms. One in terms of pi and the second in terms of 3.14. So rounding the second one to a decimal. So in this first example, looking at this picture here, we want to find out what is this sector area. Now the central angle is 210, the radius is 3. So 210 over 360 times pi r squared. So notice what they did here was they simplified the fraction. 210 over 360 reduces to 7 over 12. 3 squared is 9. And then they reduced or simplified 7 over 12 times 9 to 21 over 4. Now this part's kind of tricky, so I'm going to kind of show you guys how they did that over here. So imagine you have 7 over 12 times 9. Well, let's put this 9 over 1, and what we could do is we could cross reduce. So 9 and 12, I could divide 3 from a 9 and 3 from 12. What happens is that this becomes 3 and this becomes 4. So you end up having 7 over 4 times 3 over 1, which becomes 21 over 4. So again, this is called cross reducing. So it's reducing before multiplying fractions. So then we have 21 over 4 pi. Then the next step that they did was they multiplied 21 times 3.14. So let me write that over here. They did 21 times 3.14, all divided by 4. And if you type that in the calculator and round your answer to the nearest tenth, because it says round to the nearest tenth, you should get 16.5 inches squared. Now the reason why this is squared is because we're talking about area, and whenever we talk about area, our units are always squared. Okay, let's look at one more example. So the setup for these problems is pretty simple. It's just what could get complicated is simplifying the fraction. So for this example, 131 is the central angle, 12 is the radius. So we have 131 over 360 times pi times r squared. They squared 12 and they got 144. Now this is interesting what they did here. I kind of want to show you on the side. 131 over 360 times 144. Now I could put 144 over 1. Now what I'm trying to do is trying to see if I could reduce cleanly, and what I think they did was they found out that they couldn't reduce 131 over 360, but they did not want to leave such a big number as a fraction. Kind of like how they did 21 over 4. That's okay because it's kind of small, but to leave it as 131 over 360, I think they wanted to simplify it. Even though they would get a decimal, what they did was they multiplied 131 times 144 and then divided by 360. So let me get my calculator. So typing 131 times 144 divided by 360 gives us 52.4. And that's what we're going to be using, or that's what they use right here, 52.4 pi. And then the next step is just, I'll do this over here, it's just multiplying the number that we got, 52.4 times 3.14, and you end up with 164.5. Okay, so now that you've seen two examples, now it's your turn to solve two problems. So I would pause the video here and try the problems on your own. Remember that the two things that we need are the central angle and the radius. So for problem number 1, we want to find out what this sector AOB is. So we need to find out what M is first and then what R is. So let's start with M. What is the measurement of this angle here? Now this looks like a half circle, and if this is a half circle, we know a full circle is 360, so a half circle would have to be 180. So M is 180 degrees. Now if the diameter is 1.6, then the radius is half. So that would be 0.8. So we're going to start with our formula, which is A is equal to 180 over 360 times pi and then 0.8 squared. Now as a shortcut, what I'm going to do with the calculator is just type 180 times 0.8 squared divided by 360. So let me get that ready. So we're going to have 180 times 0.8 squared divided by 360, and I end up with 0.32. So this becomes 0.32 pi And then what we could do is we could multiply 0.32 times 3.14, and then we would get our other answer. And we get the area is equal to 1.0 centimeters. Okay, in the next problem, we have an angle, and then we have the radius. So this is just straightforward. We're going to set it up. Area is equal to 22.5 over 360 times pi r squared. So 24 squared. So again, this is a calculator part that we need. We're going to type 22.5 times 24 squared divided by 360, and it ends up with 36. So area is equal to 36 pi. And then if I multiply 36 times 3.14, I end up with 113.0 if I round it to the nearest tenth. Okay, so now that we know how to find the area of a sector, we're going to be applying this formula to real-world situations. Again, looking for what the central angle is formed by the arc, and then the radius. So let's read example 1. A beam from a lighthouse is visible for a distance of 3 miles. To the nearest square mile, what is the area covered by the beam as it sweeps in an arc of 150 degrees? So imagine you have a lighthouse and it's shining a light at an arc of 150 degrees. Well, this is going to be our central angle, and then this is going to be our radius. So plugging in the information, 150 over 360 times pi r squared, and then they just multiplied 5 times 9 divided by 12, and they got 3.8. And notice that they are saving this last part for the end. So the last step that they do is they multiply 3.14 times 3.8, and then they get 11.8. Okay, one more quick example. A circular garden plot with a 180-foot diameter is watered by a spray irrigation system. To the nearest square foot, what is the area that is watered as the sprinkler rotates through an angle of 50 degrees? So we have our central angle, 50 degrees. Now the diameter is 180, so we could find the radius by taking half. The radius would be 90. So 50 over 360 times pi r squared. Then just doing some basic math, 90 squared is 8100. 8100 times 5 divided by 36 gives you 1125 pi. Then multiply 3.14 times 1125, and you end up with 3532.5. So all of this could be just done in the calculator in one step. I kind of show you. So we could type 50 times 90 squared divided by 360, and we end up here, and then that times 3.14, and we end up there. Okay, so now that you've seen these two examples, now it is your turn to apply this to your own example. If you want to pause the video here and work out this problem, remember to write your answer in two forms, in terms of pi and then with pi being multiplied. So for problem number 1, to the nearest square foot, what is the area watered in example 2 as a sprinkler rotates through a semicircle? So this is based off problem number 2. We know the radius for problem number 2 was 90, and we know that the sprinkler is going to rotate through a semicircle. So what that means is, if I draw a picture, a semicircle is half a circle. So the area is equal to 180 over 360 times 2 pi, times pi r squared. So times pi times 90 squared. And as a shortcut, I'm just going to use a calculator. So what I'm going to type is 180 times 90 squared divided by 360, and I get 4,050. So this is equal to 4,050 pi, and then if I multiply 4,050 pi, I end up with 12,717. Feet squared. So again, this part of the lesson is just applying what you learned already about sector area using the same formula that we've been using. Writing our answer in two forms, in terms of pi and with pi. So that completes lesson 16.3. Now you have the lesson 16.3 homework, where you first will need to match the right equation with the given figure, and then you will need to find the sector area on your own using the formula. And then after you finish that, then go to the 16.3 lesson checkpoint, and that completes all lessons for this credit. Thank you.